for those of you who have seen us speak before, you know that I particularly like to have very interactive talks. It's super boring to just talk at a set of slides. It's boring for me, it's boring for you. But what is interesting is finding out what's going on with you. So I will often in the course of our talk ask you to raise your hand in response to questions. Now, I was raised a physicist. So what's the first thing you do when you're going to conduct an experiment? You do calibration. So, to calibrate, how many of you can raise your hands? Awesome. There we go. Very good compliance on that. So, for those of you who've been in the room, this is basic housekeeping on how to find out all the things going on with Network Service Mesh this week and how to actually get these slides. If you find me or Frederick or Nikolai or any of the other Network Service Mesh folks out here afterwards, we have stickers for you that have QR codes and the new logo. We're incredibly happy with the new logo. So, oh, power. I forgot to plug into power.
Yeah, I'll get a power cord.
There we go. Cool. So, let's talk about the journey we're about to go on together. So, to begin with, I'm going to wax a little bit philosophical about cloud-native networking. Because if you look at where things have gone in cloud native, there are these very heavy patterns that have been coming in from the app side, and we'll talk about them, about what makes applications cloud native. And they've come part of the way into how we do networking, but they haven't come all the way in yet. And I really think we want to get to fully cloud native networking. And we'll talk a little bit about how the existing Kubernetes networking API is an incredibly good example of what to do right as far as it went. Then we'll have story time. So how many folks have seen some Network Service Mesh talks before? And you know that I'm prone to story time. But we have an entirely new story for you this time. I think you'll rather like it. Then we'll talk about how Network Service Mesh works at a high level. How many folks have seen the basic sequence diagrams before for the sort of how things set up and are called in other talks? OK, not so many. We'll do a slight variation on that that gives you sort of a broader picture. And then we'll have information about how to get involved in the Network Service Mesh community. Network Service Mesh is a very broad community. We have people from a large number of companies working with us. It's very active. We've already got subgroups for documentation and use cases. And we're really interested in providing a good way to solve more interesting networking problems in the cloud-native world that are applicable across all domains. So if you have use cases, we're very interested in getting you plugged in. So, waxing philosophical. So this wall of text, which I don't expect you to read, is the cloud native definition that was put together by the CNCF talk. I highly recommend you go read it. It is incredibly well done. But nobody reads a wall of text on slides. These, however, are the things that I think are super important that I'm going to highlight here today with Frederick. Immutable infrastructure is a really important aspect of cloud native. You can't just go changing everything because you don't actually control the infrastructure you run on yourself. You're just a workload. Loosely coupled is really important for reasons that are super obvious to all of us. And who doesn't love minimal toil? Show of hands for people who like to work harder than they have to? Oh, it's always one.
So minimal toil networking. So what do we mean by minimal toil? So we start with minimal conceptual toil. So how many of you want to know everything that's going on in your network? Like who wants to know all the subnets and routes and wants to have to configure them in your pods and so on? So we have one person who likes toil in the back.
There's always one.
And so part of what we're trying to do is we say, okay, well, what is the thing that you actually want? Like the person doesn't want to have all these little things leading up to it. What they want is they want something solved for them. They want something done for them, some action. It could be something like connect me to my corporate intranet. They don't care about what the connectivity actually looks like or what the security looks like other than it has to be secure, whether there's load balancing, NAT, or all that kind of stuff in the middle. They just care about being able to get to the things that they want and not have to focus on the interface, routes, or subnets. So we also have the minimal consumption toil. So what we mean by that is that as a user, you ask for the thing that you want. I want secure internet connectivity. I want manufacturing partner network or Marsha's app connectivity. Whatever that thing is will be rendered and inserted into the environment with all context taken care of. So as a user, you don't have to focus on the little details, even though the details matter. But the details should be something that come as part of your system. They get auto-negotiated, not part of something that the user has to think really hard about.
So a really good example of minimal toil is the excellent work that the Kubernetes community has done with Kubernetes networking, right? So Kubernetes networking gives you connectivity, L3 connectivity between all of your pods. It gives you really easy and flexible security with network policies so that you can isolate pods and selectively give access to some of them. It gives you really simple but easy to use load balancing with services and endpoints. But it's mostly an intra-cluster API. Most of what the Kubernetes networking API is talking about is about the networking that happens inside your cluster. Not all of it, there are a few exceptions, but mostly. And it's a really excellent example of how to do that. So that's the conceptual minimal toil. You don't actually have to think a lot, right? Everybody can talk to everybody. Isolation is very intuitive, and so are services. Consumption is also very minimal toil in Kubernetes networking. You get connectivity out of the box. Network policies are super easy to set up. Services are super easy to set up. So it's a really good example of minimal toil networking. And we've taken a great deal of inspiration from that minimal toil.
So another thing we're a huge fan of is loose coupling. So when you are building, so application developers tend to understand this really well. You want to build something that has a very clean interface, that way you can mock what's behind it or replace it with something else with minimal change. So unfortunately, much of the previous infrastructure was not based on loose coupling. Things were very tightly coupled to specific protocols or specific applications. And so one of the things that we're trying to push very hard towards is to get that loose coupling so you could have your Lego block assembly. Say if you want to, if your operator says this particular connection to this system is dealing with sensitive data, we really need to have a special firewall and intrusion detection system there to make sure that our users remain safe. Then you should be able to easily add these type of things in as part of the policy and not have it so strongly coupled that you cannot, where it basically is like a giant black box. You can't actually work out what's going on. And when you start looking at the operational side as well, if you have things that are black boxes, that means you can't observe them. You can't fix them in an easy way. And in the worst case scenario, fixing them might even be blow away everything and have downtime that could lose your company millions of dollars or more. Not even looking at the reputation side.
So one other quick thing, I forgot to mention this up front and I should have. Please ask questions as we go. It makes it enormously more fun for everyone. If there's a question that you have in your mind, it is almost certainly true that other people are wondering the same thing, and you do everybody a service by asking it.
How many people here like nerd knobs?
All nerds like nerd knobs. So there's an interesting kind of strong coupling that has become so pervasive in the world around networking that we don't even think about it. But if you start thinking about it, you start realizing how terrible it's making your life. And that is, our networking is strongly coupled to the infrastructure that it lives in. Kubernetes gives you inter-cluster networking within a particular cluster. So you have networking, but it's pegged to your cluster. Your servers are using data center networking that is pegged to your data center. If you're running a VM of some sort, it has networking that's pegged to your VM. If you're running in the public cloud, you have a VPC that is pegged to your public cloud. So everywhere you turn, everything in the world is becoming loosely coupled, except for your networking, which is strongly coupled to the thing you don't care about, which is your infrastructure. We would like to see that networking become loosely coupled to the infrastructure so it can bind more tightly to the needs of the application developer.
And if you are the application developer, the VNF, or we're saying CNF, Cloud Native Network Function developer, then having that loose coupling means you don't have to worry about what comes before or comes afterwards. You design your application to the best implementation that you're capable of providing, and what comes before or after is is not your concern, and it makes it very easy for you to focus only on the value that you're trying to provide.
So, and one of the things that's problematic about the pegging of the particular network service to the infrastructure is you have an infrastructure that provides precisely one network service to every workload in that infrastructure. The granularity you're dealing with is exceptionally coarse. If I have a VPC, I have a bunch of things running on that VPC. The service provided by that VPC is available to a bunch of workloads that may have entirely different needs, wants, and desires from their network. So the granularity becomes an important issue as well.
Okay, so we have a couple examples. So Kubernetes API has been loosely coupled to the implementation. There are many CNI plugins. How many of you have tried different CNI plugins? Did you have heaps of different trouble between where one application would only work on one CNI and not on another? Or did it just work across once you got the CNI part working? So this is a good example of loose coupling. And so we also have some strongly coupled portions of the cluster. So when you run your cluster, you generally can only have one CNI. And there's some ways around this, but generally you have one CNI to a cluster. So it's an example of strong clustering. You have a single edge for your entire cluster or possibly multiple clusters. So you have to, so when you start looking at granularity, and you start looking at like what workloads do you have, that means that if you only have one knob that you can turn, and one application wants you to turn that knob far to the left and the other one wants to turn that knob all the way to the right, your only place you could probably stick it is in the center, and both applications will be unhappy. So getting that coarse granularity and being able to apply it towards different applications is something that's really, really difficult at this point.
So the third thing I mentioned was immutable infrastructure. And this is the realization, and this is super important, that effectively when you deploy a workload into Kubernetes or anything else, that pod, that workload, isn't going to change the infrastructure. It's going to use it. And the same has to be true if I'm going to deploy a pod that is going to provide a network service to other workloads, right? I shouldn't be mucking with the kernel or inserting kernel modules to do that. I need to be able to have a way to run something that processes packets to provide special networking functions in exactly the same way that I would run any other pod in the cluster.
And that pod should be unprivileged.
Unprivileged, definitely. So you can see some of this graphically up here. You have a server, you're running Kubernetes on it. Network service mesh is running on top of Kubernetes. And then you have various network services that are provided via network service mesh. And then you may have pods running on top consuming all of it.
Woohoo, story time.
How many folks like stories? It's a fundamental thing about being human, liking stories. It's a very good way to communicate things. So we like to tell stories.
So meet Marsha. Marsha is a friend of Sarah, and she is building an application that has a lot of multi-cloud and hybrid cloud aspects. So she's running lots of clouds and lots of hybrid things in that cloud.
Yep. So Marsha may have Kubernetes clusters running in various public clouds, possibly more than one. She may have Kubernetes clusters running on-prem at data centers, possibly on-prem at industrial sites, at branch locations. Kubernetes clusters are popping up everywhere. She may also have some legacy VMs that are running in some kind of a Vim somewhere that are also part of the application that she's building. And there may even be things running on bare metal behind some internet gateway that she also needs to reach, some giant Oracle database running on a server. And so these are all pieces of the puzzle that she has to interact with the microservices she's writing in her application.
Does this resemble anyone's current environment out of curiosity? So we got a couple people.
And for those of you who does, how happy is your experience so far? It's super painful. As beautiful as Kubernetes networking makes it living inside the cluster, once you actually have to get out in an interconnected way to resources that are not globally available to the world, everything gets complicated, and complicated is bad.
Complicated means when something breaks, you can't fix it.
Right. So obviously in all these environments, you've still got the Kubernetes networking and the on-prem and the cloud environment. That still has to be there because applications rely on it. There's whatever networking is provided by your Vim and your VM environment. you have whatever networking is going on with the internet gateways, but with the current mechanisms you would use to link these together with things like direct links, IPsec tunnels from VPCs, et cetera, you run into the following problem. And the problem is, I don't actually want to connect clusters to clusters. I want to connect workloads to workloads. And so to connect clusters to clusters, I introduce all kinds of complexity in terms of having to introduce security across the thing. All the ways of doing this are bespoke and complicated and painful. It's a very unhappy experience. Again, how many of you are experiencing something like this or see something like this in your future? OK, so this is the ghost of Christmas future for some of you.
Or present.
Present for others. Have any of you actually found a way that has not been painful to solve this so far? OK, that's what I expected. Good, it means we're solving a real problem.
So before we move on to the next slide, I'd also like to point out that the salmon-colored lines are connecting directly to the big center boxes. So it's highlighting, so this is important moving on to the next slide.
It is. They're connecting clusters, not workloads.
And when we move to here, we can see that we're now connecting workloads to other workloads, not clusters to
This
clusters.
is what people actually want. You have microservices that have to be able to talk to other microservices. So how many of you actually care to have to deal with the granular detail of where your microservices live when you interconnect them? That's roughly what I expected. And that's the wonder and beauty of living inside the same cluster. If you're living inside the same cluster, you don't have to worry about where your peer microservices live. But if you're dealing with microservices that are not broadly available in a public sense, that are in some way restricted, spread across multiple infrastructures, this is an unsolved problem up until this point. And this is where network service mesh comes in. Because what network service mesh is intended to do is to allow individual workloads to connect to the network service that actually meets their needs in a way that is independent of the particular infrastructure you're running on. So you can use it to, say for example, you wanted to connect together an application that you're running in a public cloud to a database that's running on-prem. That's a very particular network service. There's a small number of things on-prem that a particular workload needs to be able to talk to. Maybe you have particular security appliances that have to be interposed in that conversation that your InfoSec people are insisting upon. Those are all things that are going to give you slightly different implementation details for that network service, and you need to be able to get the thing that you need without having to think about it as a developer. The thing you want is the named network service. That's it.
So we have here, Marsha's app connectivity provides her with the correct connectivity, security, and various other services for her application. And so again, so usually when I think of network service mesh, like trying to build a mental model of what we're trying to solve, I usually try to separate it into we'll say three in a scenario of types of users that we care about in this scenario. So one of them is the person who is consuming the network service. So in this case, this is Marsha. So Marsha wants some app connectivity that gets all the connectivity, security, and so on. The second type of user that we care about is the operator. The operator who has to decide what does that connectivity, security, and other services look like, and give them an easy way to define this list of things. The third thing is the person or companies, the vendors who are providing that thing that is security or that thing that is connectivity or that other service, and give them a very easy entry point so that they can get injected into those environments based upon the needs of the operator. So we have these three needs that we have to balance. And so when we build out network service mesh, we're very cognizant of trying to keep that separation in a very clean way, with very clean abstracts, very clean declarative formats. And so
I mean, I want to double click on precisely what this network service is to Marsha, right? This network service is a thing which gives her secure, for some value of secure she doesn't want to understand too well, L3 connectivity, not to the things in her particular cluster. She still has that via the Kubernetes networking that is still available to her, but to the other microservices wherever they may be, on-prem, in other public clouds, on bare metal servers providing Oracle databases, wherever, that is the network service that Marsha is getting connected to by network service mesh in this story. Now, you can have others. We're very flexible on that point. Network service mesh is ambitiously unambitious. We connect you to network services. We don't insist on what they have to be.
So minimal toil. So how does Marsha say, please connect me to Marsha's app connectivity? So if you take a look up here, we have an annotation. The annotation is ns.networking-service-mesh.io. So this goes into in this scenario, the metadata of the pod. And she specifies the thing that she wants. And so what Network Service Mesh will do is it'll use this information to connect Marsha to Marsha's app connectivity.
Yep. So ask for what you want. That's it.
So in a nutshell, like as a consumer, if all you need is a kernel interface to something that you want, this is as complex as it gets for Marsha's viewpoint.
Yep. So loose coupling. So we've been talking about loose coupling, and I've beaten a couple of times on the point that we peg our networking to the particular infrastructure, to the particular cluster, to the particular public cloud VPC in a way that's actually not helpful. It's a relic. It's an artifact of the fact that we needed networking somewhere, and so somebody built it to the thing that was attached to the infrastructure they understood. Network Service Mesh allows you to loosely couple your networking to your infrastructure so that the networking that your application gets, no matter where it's running, its many parts may be scattered, is a single network service that does the things that it needs, right? You have some magical load balancing behavior that you like that's different than what you normally get. You can build that into your network service. You have some particular set of IPS or other security requirements. You can build that into your network service. Your InfoSec people want particular net flow information so they can monitor for problems that they may be seeing in the network. You can build that into your network service. And you can connect all the many pieces of the workload to that network service without having to peg them to this cluster, this public cloud, this on-prem data center.
Yeah, speaking of loose coupling, if Marsha's app connectivity changes its definition, I mean, that's really good coupling, loose coupling, because Marsha doesn't have to change anything there.
True. Marsha doesn't have to understand how the sausage is made.
So immutable infrastructure. So immutable infrastructure is something where when you want to establish your infrastructure in a very specific way, and the pods, the workloads that you are running, should not have the ability to manipulate and mutate that infrastructure underneath of them. So the infrastructure gets provided, and they consume the infrastructure, but they're not able to change that infrastructure themselves without the help of a scheduler or of the infrastructure itself. And so day zero. So the general day way that it looks is when you're installing Network Service Mesh. Day zero is helm install NSM.
Congratulations, your Kubernetes cluster is now NSM enabled.
Day one, we found the thing that we want to run, so we'll do helm install Marsha's app connectivity.
Congratulations, you now have a network service available in your cluster for Marsha to use for our app connectivity.
So surely this must have changed something under Kubernetes and everything must be broken?
No. So the nice thing about Network Service Mesh is we don't require any changes in Kubernetes. Kubernetes is perfectly fine for this purpose already. You just have to use it intelligently. We also don't require any particular CNI. The way that most people have approached having needs that are greater than the Kubernetes API in the past has been, we will hack the CNI. And this has a number of problems. The first problem is, to get the thing you want, you have to run the particular CNI that provides it, and you basically more or less get one CNI per cluster. You're back to the fighting over which direction the knob turns. We don't do that at all. Network Service Mesh is completely orthogonal to CNI. It doesn't touch it, it leaves it alone, it continues to provide your Kubernetes networking that you know and love in exactly the way it's there. And this also means we don't have the opportunity to break it. We go to great lengths to make sure that no matter what happens, we do not interfere in any way with the Kubernetes networking that you know and love, because that's what keeps your intra-cluster stuff working, and that is finely tuned for a particular purpose and should be left alone. How many folks actually like Kubernetes networking? Ah, interesting, I expected more. It's super nice as far as it goes. So for the folks who didn't raise their hands, is it because it doesn't do something you want? So how many folks is there just something you want that it doesn't do? Okay, I expected more than that. Anyway, but this is actually really important. It's a minimal impact. It's actually a very immutable infrastructure way of approaching the problem. Kubernetes does things well. We don't need to fix it. We just need to enhance it.
So in terms of network service mesh, so we've been building AI to work on Google's cloud infrastructure, on Azure, and on Elastic. We also have vanilla Kubernetes on bare metal. We've actually been testing that with the packet.net. For those of you who are the sneaky network people, we've been testing things with DPDK and other similar things. So every time that you submit a patch, we go through the full CI on this through this environment, and so this is going to have two effects. Number one is that over time we're going to flush out all the bugs that appear on the networking side, because. And not just on our side, but actually we've been finding bugs with providers. And so
I wouldn't call them bugs, just they fail to do things that would be convenient for us if they did them, sometimes in surprising ways.
Rather than say bugs, we'll see if I can give a good example. Like GKE is a really great example. If there's something that they don't use in the kernel, they just strip it out.
Which is good practice. And stripped out some things that we would prefer to use but can't now, but we have other things we can use. So. I mean, the whole point here is we're here to demonstrably prove that we run on immutable infrastructure. And the way that you do that is by running your CI on as many different environments as are available to you. So we run across the public cloud so that we know that it always works on all the public managed Kubernetes. So that we know that when we say just type helm install NSM, you can go and type helm install NSM on your GKE cluster, on your AKS cluster, on your EKS cluster, and get the thing that we're building here.
Yeah, one of our goals is if you are running if you are building the network service itself, you should be able to, as the provider, be able to generate the thing that you want, implement the thing that you want, and have it run on any of these things, and with minimal to zero differences between them. So truly like bringing cloud native networking.
Yep.
So how the magic works.
So quick question, how many of you guys are actually curious how we do this?
Woo!
And to how many of you does it actually sound like magic? Oh, excellent. Cool. So how the magic works. So I'm going to start talking a little bit abstractly to begin with, right? So you have a network service registry. Anybody who's got any kind of a mesh for services of any kind, and we're just dealing with a mesh that does things for packets instead of for HTTP headers. Anyone who's doing that has got to have some kind of a registry that you register your services with, so that when you go to do service discovery as a system, that can work. Network Service Mesh has one as well. Now, we've constructed it in a way that's fairly agnostic as to where it's stored, because our ambitions are not to weld ourselves to Kubernetes. We love Kubernetes. We do a lot with Kubernetes. But there's a lot of legacy workloads that need to be part of the Network Service Mesh as well. So in Kubernetes, we happen to be using the Kubernetes API server as our network service registry. But there, you don't have to. There are lots of other ways you could do it.
So how many of you have heard of gRPC? So we use gRPC to create the protocol, the abstract definition itself. And so when you connect to the registry, you're actually connecting over gRPC, and then that service in the background is then storing them in Kubernetes. But you could, if you really wanted to, and you decided we're not going to use Kubernetes anymore for storing this stuff, I mean, you can stick whatever database you want in the background, as provided you just implement the API.
Yep, exactly. So and that's where we store information about the network services, the network service endpoints, all the rest of that stuff.
And the managers, you'll see this in a moment.
Yep. So the next concept we have is these things we call network service managers. And you can think of these this way. They're sort of like hyper-local control planes. You can almost think of them as kubelet for the network service mesh. In Kubernetes, they run one per node as a daemon set. And their job is to be able to handle the service discovery, service routing, and connection management for providing those virtual wires. Because there's no standard way to do connection management for virtual wires that carry packets or Ethernet frames. So we have to provide that as well. So those are the second component. They're hyperlocal control planes. Think of them like kubelet for the network service mesh. And they have some domain that they run in. In Kubernetes, they'd be a single node. And that means that there's a set of clients, things that consume network services, network service endpoints that provide network services, and possibly some data plane element that cross-connects between them that lives in that particular domain. All of those are managed by the network service manager. So a client comes up and says, I want a network service. So it turns to its network service manager. The network service manager then turns to the network service registry with a gRPC call and says, I've been asked for this network service. Please tell me all the things I need to know. And it gets back the network service, any policy associated with it, and a list of the network service endpoints that provide it. From that point, the network service manager can establish a set of candidates to connect to, just like if you were doing this with any other service mesh. And it can pick one and go to connect. And that looks like another gRPC call going peer-to-peer between the network service managers. It turns out that the way Kubernetes fundamentally thinks, and it's the way that scales, is to have a small number of local control loops that have the minimal amount of central data and interaction in order to function at all. And that's exactly what network service mesh does. We do not have a big brain in the sky controller. Instead, we have interactions peer-to-peer. And this request would basically have one network service manager asking the other, hey, please give me a connection to, that carries packets or Ethernet frames to this network service that you registered as being under your purview. And here's the list of in-cap types that I would prefer in preference order. Maybe I would rather use SRv6, but I could also use VXLAN. Maybe I could also use GRE.
So for those of you who are not familiar with NCAPs, that's where if you wanted to have like a private network on top of another network, then NCAP will give you that.
Yep. It's the muddy details that you never have to see as a user, because we negotiate it all. You never have to worry about it as a user of network service mesh. Yep. And having negotiated that process with the request, then the network service managers cause this point-to-point connection to come up between the client and the endpoint. Yes? Is this connection a third-line connection? So yes. Yes.
Yep.
Because you know precisely who you're talking to. It's the granularity issue again. Now, there are ways in which this can be handled. So probably what you're concerned about is the proliferation of interfaces. So the proliferation of interfaces on the kernel side is a problem. The kernel doesn't scale well for interfaces. If you're actually building a network service endpoint, there are more exotic options like MEMIF that will happily scale quite trivially to having tens of thousands of interfaces in a single network service endpoint without a lot of difficulty at all. So basically, if you're at all serious in terms of writing a scalable network service endpoint, it's super simple. And because network service mesh will handle the transliteration for you, you don't have to worry about what your client is plugged into. It can have a kernel interface. There can be an intervening tunnel. And when it pops up to you, it shows up as whatever kind of thing you wanted the network service mesh to give you as an interface type.
And that also means you never have a multi-hop connection between the source and destination.
Nope. Well, I mean, so when you say multi-hop, do you mean multi-hop or do you mean a multi-point?
Multi-hop in the sense that when my client wants to talk to a far-away server,
yep.
The network service manager from the client and the network service manager from the destination, they always
well, but please note, it's connecting to a network service endpoint, something that provides a network service, right? So if that may be itself a virtual router, it may be some kind of other virtual thing that is multi-point, that is doing more complicated things. So it's not like I'm doing a midi-midi connection between every pod and every pod in the system. That wouldn't scale. But I'm saying, look, there is something smart that gives me the network service that I want. I'm going to connect the people who want it to that thing. And of course, I can also do replicas of that like anything else in cloud native and handle that for both resiliency and scalability.
Yeah, there's some really great use cases where you really want to have that multi-point. So when you start looking at things like multicasting with video or so on, then
oh yeah. I mean, if you want to dive deeper into the details, there's going to be a brainstorming session at the Hub Lounge. It's on the events page. That's a really good venue to talk about these kinds of details because I'm delighted to talk about them, but we've got a broad audience.
Yeah.
Cool. So what we just described to you is literally what happens inside a single domain, which you can think of as like a single cluster. So that we have implemented today, it works. Where we're going, and what we're going to be implementing very shortly, is interdomain. And interdomain literally means that I have two separate domains, multiple clusters, possibly other places, and I would like them to actually be able to interact with each other's network services. And so for interdomain, when a client comes up and says, hey, network service manager, I would like a network service, instead of asking for, go ahead. Instead of asking for something like Marsha's, Marsha's network service, I could ask for Marsha's app connectivity. I could ask for Marsha's app connectivity .example.com. And we'll interpret that .example.com as the domain of the network service you want to connect to. Then the network service manager, back one, simply looks up a service record in DNS for the service registry for that domain. It's a very simple mechanism. It just lets us find the service registry for that domain. And then once we've done that, we use exactly the same gRPC call we used before when we were in a single domain to ask exactly the same question, just from the different registry. And we make exactly the same request to a peer that we made before. It just so happens that this peer network service manager is living in a different domain. Please note there's authentication credentials and things going on here in the background as well. And then we stand up an L2, L3 connection, point to point, just like before, because literally, other than that first step of finding the service registry, which we do with DNS, everything functionally is the same as if we were operating in a single domain. Yes?
Is the DNS service built in?
DNS?
The DNS service, is that built in, or is it a separate service you need to maintain?
So you're asking a good question that I think is slightly off center, and we'll get it to center. So basically, DNS in general is the network service manager has to have access to DNS to be able to reach a DNS record. That part, we just presume you have access to DNS because you're writing the network service manager somewhere that has access to DNS. There's a second question that you may be asking, which is, how do I provide DNS for the L2, L3 connection that I have to something else? Is that your question, or?
No, or what updates the DNS with the service endpoints and that kind of thing? Is that
Oh, so the DNS does not know about the network service endpoints. All the DNS knows is the service record for the network service registries, which are not fast-moving objects like network services and their endpoints. Yes? How do we handle what? How do we handle the IP clashes between the domains? Okay, so this is actually a really good question. So you've subtly gotten, with the way you phrased your question, you subtly actually got to an interesting point about pegging networking to infrastructure, right? And our horrible, horrible abuse of that historically. So when network service mesh negotiates these connections, the network service itself provides the IP to be attached to the secondary interface and also routes for what's supposed to be routed to the secondary interface. Now, obviously, you don't want this to clash with the IPs of your cluster. So when the network service manager is making that request, it sends an exclude prefix list, which includes at least the cluster prefixes. So your network service is basically told when you connect, you can give me any IPs or routes you want, as long as they don't conflict with what's already happening within my domain. So if you're providing a network service and you expect to be dealing with someone who may be in a domain where you could have clashes of IPs, you as a network service provider will have to decide what strategy you're going to apply to that. Yeah, they're compatible, but they're completely independent in their management. Because global IPAM is a horrible pain in the ass. It's terrible. Avoid it at all costs.
So this gentleman
Yeah.
just
Oh,
we're
sorry.
out of time, so.
Oh, I'm sorry, we're being cut off for time. I'd be delighted to talk to folks after. I'm sure Frederick would as well. We do have, if folks want to, as we're sort of closing up, we have QR codes for past talks we've done at KubeCon that are also super helpful. We did not cover in this talk all the material that are in those talks, mostly because of time. But we'd love to talk to you guys. And please do follow the events link and get stickers. We have QR code stickers that will take you there as well.
Yeah, one last thing. If you want to get involved, if you're interested in either from a user and you want to make sure your use case works in our environment, or you want to contribute with code or documentation or anything, come get a hold of us. We will help you get involved as well.
Yep. You guys have been a great audience. You've been super fun. Thank you.